Hello and welcome to Tech Nuggets and Thoughts. I'm Nikhil Vanpal, your host. And today's topic of discussion is containers. Now, containers are not really a new term or a technology. They've been around for quite some time and you might have heard about it already. There's another term which you most likely would have heard. It's called VMs or virtual machines. You might already have used VMs to play around with, to run some programs that are incompatible with your OS, or things like that. Or if you worked on cloud, you're sure you've used VMs because everything on cloud happens on a VM. Containers are just like that, except that there's no hardware virtualization in case of containers. What does that mean? In case of a VM, the operating system running inside the VM believes that it is running on a physical machine. But the container knows that it is not a physical machine. It's rather a compartment. It's rather isolated environment inside which it is running, and that is why it is called a container. So how is this achieved? There are some technical jargons we don't really need to know to be able to use containers. But anyway, if you would like to know, remember these names. One is namespaces, which basically allows to create an isolated environment for containers to run in. Then there's something called as C groups or control groups, which basically allows to limit the resources or even control how much of a particular resource is available to a container. And then there's something called as union file systems. Based on this, I think it is pretty clear that container is something internal to the Linux kernel. Now, how do you use it? You don't have to do the mumbo jumbo with the kernel. There are many solutions already out there that let you use it. You might already have heard some of their names. Let's say one is Rocket from CoreOS. One is Docker, of course. It is the most popular implementation of containers. Actually, it is believed that even before Docker became popular, containers were in active use. One such example is believed to be Borg, which was Google's implementation, which they used for a large-scale deployment of Google's platform, which later is believed to have become Kubernetes. That's for later, though. So let's talk about Docker. What Docker does is it makes use of these things, these features from Linux kernel, and make them available to us in a very, very easy form. Now, Docker itself is composed of three main parts. There's one called Docker daemon, or the background process, to which you send commands using a program called Docker CLI and download images from something called as Docker registry. Now, Docker registry is pretty much like your App Store or Google Play Store. It's a hub. It's like GitHub for Docker images. I mentioned an image. So what is an image? There were images in case of VMs. Now there are images in case of containers as well. The image is actually your executable. It is the pre-configured bundled application that you are going to run. And image is essentially immutable. It's like a class in an object-oriented language. And when you create an instance of a class, like an object, we call it a container. So containers are runtime instances of these images. And of course they are mutable, but they're not persistent unless you mount a persistent storage into them. So anything that you modify in a container is lost when the container dies. Now wait a second, I think I mentioned that images are bundled applications, but I did not mention bundled with what. So essentially images are your applications bundled along with their dependencies and setup requirements. Any external files that you need, unless they are environment specific, would be bundled, packaged into a single file along with the operating system binaries or operating system libraries of your choice. All of that, yes, except the kernel and the virtualizer. Now what does that mean is something we'll see when we talk about our next point, which is why use Docker. So to understand the use case, we need to look at how Docker or VMs work. So if you are working on cloud, so anything in cloud is in a VM, right? So what you're essentially doing is you're asking Google or Amazon or Azure basically to provision a virtual machine on their racks, in their hardware, on their computer, and provide it to you for usage, right? So that's a VM. Now, what you can relate this with is how you rent an apartment in an apartment complex. So, assume a building or a complex with multiple apartments. You go there, you get rent or basically buy an apartment in an apartment complex. You're staying there. That's like having a VM in cloud. Now, now in your house, if you were to ensure the maximum usage of the apartment, what can you do? You'll rent it out through, let's say, Airbnb, right? Exactly. So what happens is when you're not using your house or a portion of your house, you basically earn money on it uh, by renting that portion to someone else, right? This is exactly how a Docker or a container works. So instead of having a single dedicated VM to your application, you can have the VM shared between multiple applications running inside containers. And that is what we do. So how it works is basically, as they are compartmentalized, the applications have absolutely no knowledge of the other applications running inside the same VM, although they are using the same RAM, same CPU cycles, also the same hard disk. So let's say your application is running at an idling requirement of RAM, let's say 2 GB, and at peak it can scale up to, it may end up using up to 4 GBs of RAM. In such a scenario, you can keep running 2 instances of the same application inside the same VM, inside containers, at an idle state, right? Only when you need to scale, you'll need to have higher RAM, more RAM, and till then, you don't have to pay for the additional machine. It's that simple, okay? So that's about the usage of the resources. But why use Docker? We've already seen the Airbnb reason. I believe that the more important reason is the consistent setup that Docker gives us. So basically it abstracts out the underlying setup or the libraries required for your application to run. Not just that, it also abstracts out how your application is started. So basically you code how your application is started and the setup in your image, basically the Docker file. And once the image is created, there's only one way to start the image, using Docker commands, and Docker knows how to start the image. So there's a consistent way of starting any application, irrespective of what the application has, what language it needs, what framework it needs, what all dependencies it has. There's always a single and consistent way to start the application, stop the application, anything you want to do with the application, basically. Apart from that, the next important reason I would say is the way Docker basically makes the environment a part of the application itself. You can then ensure that the entire flow of your application from various stages, from your developer's machine to production, uses the exact same versions and set of dependencies in the exact same manner. Now it matters because I've personally seen that some of the queries that I would write in, let's say, 5.7.12 of MySQL don't work in 5.7.14. Now it's a point version change. Shouldn't really be that big, but yeah, that happens. And you don't want that to happen in your pre-prod or in your prod environment. So it's better that it happens on your developer's machine, or it never happens at all, basically. So your developers write their code, their anything that they build is basically built against the exact same dependencies and requirements and environment that is there in production. So you basically get rid of any and all such issues. Then the third important reason to use Docker would be how easy it makes to CI or CD your application. Basically, it is easy to integrate with any continuous integration environment or setup that you have. It becomes an artifact. So earlier you used to build wars or basically jars. Now you build Docker images and push to Docker registry. Simple as that. And now that this artifact is built, you can pull it anywhere. You can spawn the entire stack of your application inside your automation setup without requiring a lot of other virtual machines and test against it. So it becomes very easy to have continuous integration set up. It becomes very easy to get continuous deployments working. Of course, you need tests for that. Never ever do CD without tests. That's a different topic though. We'll come back to that later. That was from developer perspective. Thinking from security perspective, Docker. Okay, this is interesting. So Docker has layered setup, or the image is basically built with extending from immutable images. So your application is a layer on the immutable image from which it extends. So it's actually it lies on a different layer, meaning that underlying layer can be modified. What it means is, again, your application is again decoupled from your OS, or the relation with the containers OS and your application is coded in your Docker file, right? So one of the most important things about security is patching your dependencies, right? So if you don't patch them, you're sure to have vulnerabilities, and you're sure to face some of the other issue whenever it happens. And it's that one time that you didn't patch and it happens. So it's better to patch, but it's cumbersome. So how do you solve it? Since your application and the underlying OS lies in different layers, it's easy to pull the latest version of the OS and build your application on top of it. Again, you have the setup, so need not worry about it, so that you can remain updated as well. So that's again from security perspective. Then again, the containers are being completely decoupled from the host OS that they are running in. A container can't really impact or cause damage to the host OS, unless of course it is running as a privileged container. Now that's something, a pseudo thing, so let's not get into that. So you would never run a production container in a privileged mode. So that's not something of a concern as a casual user of Docker. Hold on, did I just say never? Never say never. So yeah, it is difficult, I would say, to impact your host OS. Okay, so we've seen all the beauty that it brings to deployment and development environments. Now what about production? So VMs are known to start very slow, right? Because the entire OS has to load. The hardware virtualizer has to load first, and like the OS, then your application. If your application is Java, there's again another VM in between. That's not how Docker has, basically. Since we skipped the virtualizer layer, it's pretty easy. Basically, it is like linking directly to the kernel, right? So it starts instantaneously. It's way faster than virtual machines. So it's fast to start, and your application is still going to take the time that it is going to take normally, basically. So you can't, if your Spring application, let's say talk about Spring Boot, if your Spring Boot application takes like 10 seconds to start up and get ready, your container is going to take, let's say, close to 10.5 or 11 seconds to start up and get ready, and as opposed to a VM, which will take close to 30 seconds plus 10 seconds. So yeah, in production as well, it starts pretty fast and it's easy to discard. So pushing your images or a newer version to production is pretty easy, because you can just discard old containers, spawn up new with the new version of image that you just pushed. Now here's the thing. In case of VMs, we didn't really worry about being stateless, right? You're supposed to. If you think of it, actually your VMs once stopped or lost, there's no way to recover the data, right? We're talking about the VMs in cloud. So you should anyways have a mechanism of pulling content or generated files out of the VM, right? And we don't really value it as much. I've seen people not care about it at all, but you should have a way of pulling logs out of your VM anyway, right? So it's no different with Docker. Once a container is basically stopped, or basically removed, I should say. Once a container is removed, there's no way to get what was inside the container. If a container is just stopped, you can restart it, but that's not what we talk about in production, right? So it's better to have, no, it's not better, it's necessary to have all your transactional data or any files that are generated during the application's runtime, to pick them and move them away from the container. So you need to have your logs pulled out. You need to have anything else you generate. Let's say if you are you have file upload, you need to have an external file system mounted inside the container to place the files in it, or maybe a database to contain the files. For logs, you should use something like Filebeat and pull them out, or just route it to containers output and move them. That's not very great actually. It becomes difficult to distinguish between different types of logs. So I tend to have my logs separated into separate files, right? Error, fatal, and information or debug logs. So piping it into containers output is not the best thing. What we can do is we can pull those files out continuously, stream them out of the container into a persistent storage outside. So that's something we need to be worried about. Take care of in production. Now the thing about containers is it's not the same as a VM, right? It needs a lifecycle management. It needs an orchestration framework. So what it means by an orchestration framework is that some way of handling lifecycle of the container. So when you push a new image to the image registry, there should be a way to identify and remove your old containers one by one so that your application doesn't go down, and start new instances of your images. And when your application is under load, automatically the orchestration framework or container management software should be able to scale your number of instances, the containers, to use more and more resources. When there's no load, it should be able to scale down. Now there are many such orchestration frameworks. Like Docker has its own called Docker Swarm. There's Kubernetes, which I love basically. Then various vendors have built their own basically. So Google Container Engine is one, which is like Kubernetes, a managed Kubernetes in cloud, in Google Cloud. Then there's Amazon's container service. Then IBM has its own. Then there's one from Red Hat. Then there are ways of managing like where your containers run. Let's say something like OpenStack, which will allow us to have hybrid cloud environments with containers in it. It gets very complex with that and things like this. But the container, the orchestration framework is basically responsible for identifying or setting up the life cycle of the container. So basically, when more containers are required, it will scale up. It will scale down when the containers are no longer required. It'll refresh the containers. It'll establish resources. It'll limit or control the resources that are available to a container. Now we didn't discuss this, but it is possible to control how much RAM a particular container uses, or how much hard disk can you allot. I'm not very sure about the hard disk though. But I've seen RAM which can be controlled at runtime. So all such things are basically defined in a configuration file and fed to orchestration frameworks like Kubernetes, and then it takes care of the entire application's lifecycle, right? So when you start the application, it'll spawn up all the containers that are needed to be started, and then it'll establish interactions between them by setting up networks, or setting up links, or DNS discoveries, whatever the container orchestration framework uses. Based on that, now you have a virtual setup inside the VM. So yeah, even VM was a virtual setup, but yes, inside the VM you have mini virtual VMs, virtual VMs, which are now talking to each other via this orchestration framework. They are keeping themselves up and running, doing hosting your or running your application. But nothing is ever all good, right? There are always drawbacks to every single thing that we ever see in life. So what are the drawbacks of Docker? Well, one of the first things that I have always noticed is how cumbersome it is to explain what Docker is, or how difficult it was to understand what Docker is supposed to do, what problem is it supposed to solve, and what exactly is this thing. It has a bit of a learning curve. to get used to Docker, it takes time, it takes some understanding and effort. That's probably because it is new. The new kids, as they come into the industry, probably they'll already know what Docker or containers are, or maybe whatever the container of that time is. I don't know, but it feels like Docker is difficult to explain and get used to. Then the other thing we already saw is how the containers being temporary. We need to be extra careful about the data that we put inside container or generate, especially inside the container. Another thing is Docker being an additional artifact, or Docker being a layer between your machines and your application. It is, if you think of it, is actually a complexity which you have to deal with. But it's a good thing to have, and I believe that the applications of Docker, or the benefits of Docker, supersede the drawbacks that we face so far. Okay, I think that's all about Docker for now. Okay, the other point that I had on my list was introduction. Of course, this being the first session, I should introduce myself and what I'm doing here, right? Well, I already told you, my name is Nikhil Vanpal, and by now it is pretty obvious that I love technology, right? So that's about me. Other than this, what I do for my day job is, of course, I'm a software developer and architect, and I love riding bicycle and motorcycles. And that's where actually this whole thing about podcasts comes from. I love to listen to podcasts when I'm riding, and thought, why not? I love to read up, I love to study, and I love to share what I've learned, right? So I thought I'll start a podcast. And so here we are. And now, as to what we are doing here, what I intend to do with this podcast is basically discuss technology, but not just the whole technology. I can't pick a topic like microservices and finish in one discussion, of course, right? And that's why it's called Tech Nuggets. And of course, I have thoughts and opinions, and I'll be sharing them. You have all the right. And yeah, the obligatory declaration. Any opinion that I express in this podcast are my own and not of any employer I've ever worked with or will work with in future. So, and you have all the right to disagree with an opinion I express. So, and I would love to hear about it. So feel free to reach out to me. I would love to have a discussion. So, also, if you have any topic that you believe we should cover, we should discuss, do send them out. Would love to go through them, would love to work on them, study on them. And so I think that's all for today. See you next time. Until then, bye-bye.